Greeting.
Yeah, hey. Um, cool. So I guess we can get started for the day. Before we kick off with the signups, does anybody have questions or comments about the study group or anything related, anything like admin related? Or I know we talked a little bit about the boot camp links already. Sent those in the channel. If there's nothing to bring up, then we can get started. All right. Cool. Let's just have a look at the participants. No, signups. Yeah, there we go. Cool. All right. We have Zane, myself, and Quiet Catalyst signed up today. Elbeth or Ratio, did you guys want to reserve any time for the agenda? Or are you just
No,
kind of
please,
here to
not
hang out?
today.
Cool.
Yeah,
If
no,
you can
thank you.
please for the boot camp, then it's fine for me. But I'm not doing any presentation.
Cool. Okay. No worries. Yeah. Just hang out, listen in. Cool. Then I don't think I'm forgetting anything. My brain's always so fried by this time of the day, so it takes 10 minutes to think of a sentence. But I don't think I'm forgetting anything, and I think we could just jump right into it. So I will pass it off to Zane. Do you want to get started with Pico updates?
All right. Yeah. So, not too much going, but a little bit of something. So let's go. Let's go here.
And
Go live.
I'm curious what you thought of that, if you had a chance to read that article yet.
I had skimmed it before, but I didn't really get a chance to deep dive. So I'm still catching up.
Yeah.
So I'll have to give you feedback, probably async
Cool.
after the call.
Yeah, no
But
worries.
thanks for sharing it.
Yeah, it's kind of it doesn't have like direct relationship to your project, but it talks about service DAOs and like some of the challenges, and just about like retaining talent and stuff, which I know is some of what you had mentioned in your project. So
Yeah, for sure. What did I do? Okay, I'm gonna drop this closer to this because it's more relevant. Okay, I'll give a bit of a recap. So PicoDAO is basically an idea that I had for creating a short-term DAO. So just for people that haven't joined, and so the basic idea is, can you figure out a way to create open economies for projects?
did my audio cut out? Huh. Hmm.
Put up 100K, but you may expect a 3x return or 33% return. Your expectations pretty much no matter what the economic model is, even if it's an NFT 10K profile pic drop. So the economic black box model feeds into the total available funding as well. So if you're collecting fees, if you're an exchange, or you're even collecting royalties on resales from NFTs, that does affect your total available funding. And so like the worldview is basically roadmaps have impact, what this economic black box model has impact, and then the developer cycle has impact. Okay, so that's kind of the established work from before, and these are like called causal loop diagrams. And now that we're kind of up to speed, the thing I've been trying to do is take these cycles and build sort of layers of abstraction that we can then use to model lots of different economic black box scenarios. So the idea is if I can sort of abstract away this development cycle and then like have a way to view the way that maybe the breadth of knowledge network increases or the depth of the knowledge network, and then have a way to see how the economics of this affect these kind of levers, then it's a general kind of framework for being able to build these kind of simulations. And the other kind of way I view it is like on the right-hand side is this funding cycle, which abstractly is the beginning of any business. So whether it's like self-funding or that's like raising VC money or it's doing an initial like token sale of some sort, these are kind of like, I don't want to call them Six Sigma events, but they're like kind of these events that like happen periodically through the life cycle of the business. So if I can model the left and the right-hand side and then broadly model the middle, then we can kind of plug and play economic models into these cycles and see if we are able to create a sustainable dynamic for open incentives for like development or creating products. And so that's very broadly where it's at. And so the question I had is, I think that the CLD is pretty well defined. There are a couple of things that have to do with specific policy decisions. And so I wanted to kind of take this to the next step. And I kind of played around with the idea between doing another, like sort of doing a stock and flow diagram, or if I wanted to do something that could kind of edge me more towards like simulation and modeling. So what I went to do is I kind of modeled this off of the Ethereum economic model that was done for ETH2 and the gas price change. And so I created a differential spec. So we dive into this. I started to try and break things down and try and capture the processes as little individual distinct processes that tie into like a larger cycle. So on the left, I have the following sort of guidelines. So we have system state inputs, which are just like the things that are state variables or like things that you need to monitor throughout the system that can be tied across multiple processes. And then here we have system inputs. And these are just kind of like the things that get like, and my understanding of this, I could be entirely wrong. They're kind of like the functions that need to like sort of update or handle the inputs more or less that come from the various like state variables and channel that into or map them into um, either different state variables or have them into sort of these applied functions. So for the funder process, what I decided to do was kind of abstract it in this kind of way.
Zane, do you think you could
Yeah.
zoom in just on one of those?
Okay, there we go.
Cool.
Awesome, thanks. I forgot. Okay, so, all right. This is the differential spec. So here are these like state variables. And so what I was trying to do is find an abstraction for like the funder process. So for the funder process, I kind of took this from the way that the theorem economic model modeled like validators, because validators can either enter into the system or be ejected. And so the same with the number of founders. And to view founders not as really individual discrete funders as individual discrete entities, but as a sort of collective group. So the number of funders that you currently have in the system, the number of potential funders, so that's the population of people that could be within your user base to become like a funder or within your investment base. And then the other thing is funding satisfaction. So if this person is one of the numbers of funders, what's the likelihood that they're dissatisfied with the performance thus far? So all of this feeds into this environmental process that I'm calling funding or funder activation, rather. And so funder activation is a product of these kind of three state variables. And the transformation that happens here is that you get the current number of funders and the current number of potential funders. And so number of funders here is the same across all the state variables, so it's not like a new funder. So the other thing I decided to do is split the funding process into different components. So one is like who are the funders and like how do they become funders? And then the other one is like what are they actually contributing to? So one of the things that I thought to do was to convert this into like a way to talk about like what is the actual process. So here we have the number of funders that we were talking about from this. And then kind of the next thing we have is this thing called a stage. So a stage is like one to talk about the business life cycle stage. So there could be an initial raise stage. There could be another like weird external capitalization event that causes there to be external funding. So this is like funding that is exogenous or extraneous to like whatever your natural process would be from your economic model. So like for instance, doing a 10K NFT drop is kind of an abnormal event. You're not going to go through that initial sale again. So that would be a particular stage. Another one would be seed funding from a VC. Another one would be bootstrapping from, like, say, yourself. And so these stages mean that when there's time for funding, you can look at the number of funders that you have available. You can look at the stage and you can say, as well as the time step, so that way you know if the time step and the stage are the same, which could be like at tick 10, there's an event that is the sale. And so you know the stage is active, you have the number of founders, and you know like roughly how much each founder is going to spend for your like population set, and then that becomes like the funding at that point. So there you've got this funding process. These are the sort of inputs to that funding process. And then you could either use a probability distribution of the number of funders and like say, like on a bell curve for each one, you roll a die for how much they fund. It doesn't really matter. It could be a stochastic process there. Here you have funding from external sources. Okay. And then if we yeah, awesome. And so like that's the external funding contribution process. And then sort of the thing that we're talking about a lot is like development funding availability. And so here we have funding from external sources. We have this idea called treasury funding, which I haven't actually broken down yet. But basically this is things that come from like the pool of cash you've either been collecting from your economic model. It could be from anywhere that you've like sort of made money. But then here's your funding period. And this is like to figure out like, oh, okay, how frequently do you do this process? So is it on a monthly basis? Is it quarterly? And then this represents the development funding process. So this is going to be a user decision. And so this is like either by committee, etc., you then determine how much of this treasury fund based on like how the duration of the period, the funding that you might have available to you from external sources. And this is kind of fuzzy because this could just feed into the treasury funding, which probably it should, saying it now. But basically you can use these three to figure out how much development funding you have available for that period. And then the thing that this process kind of spits out, or these decisions by the sort of existing constituents, becomes the funding amount. And then to just kind of break things further so that way you can kind of see how things are, you take the timestamp and the stage and you break this down into stages. So you can then say like this maps to the initial stage, like I've been running this for a long time stage, and then like you can say like, oh, this timestamp, etc. It's just a simple mapping, and it just wanted to like sort of lay it out. And then kind of the thing that I was working on that I hadn't gotten to yet was to think about like the developers, in which case this isn't really developer broadly, it's more like contributor. So a developer in my world could be a biz dev person that is doing some marketing. It could be anyone that is sort of contributing towards the benefit of the project or the product at any particular time. So you can take the number of contributors, potential contributors, and then you can apply this, not the stages, this is like a typo, but this would be towards some sort of contribution function, which would do something very similar to what we did here with funders. Okay, so that is pretty much everything to date and what I've been sort of working on. And I guess the question I have is, what do people think about like sort of breaking things down in this particular like way? Is it confusing? And then the other thing, I should probably not leave it on the confusing side. The easier one to look at is this one, a little more fleshed out. Yeah, is it confusing? Does it make sense? And like the ultimate goal is to figure out how to like sort of codify each of these processes in a way that makes it easy to simulate. or to replace the way that these like functions map. Um, yeah. So yeah, that's pretty much it for me.
So, one aspect I was struggling with a bit is you have the number of funders and the potential funders. Um, so I guess the sum of those two is like a total addressable market of funders. Is that the right way to think about it?
Yeah, that would be. So the people that are already, I guess, number of funders is really active funders, and then potential funders are people that are within the pool of people that could turn into active funders.
Yeah.
Yeah.
Okay. That's how I was thinking of it. And so maybe that implies there is some additional logic that governs how people move from that pool to be active or inactive.
Yeah, and so that logic would live within this like funders policy function, and so like that's pretty abstract. And so like in this sense, it would be something like uh, it would be more of a behavioral type of thing where you might say uh, if the funders themselves were individual agents, then they could have uh, an idea of memory between like the different timestamps. It could be like they have some individual metric of like satisfaction, and they could all have different strategies. So satisfaction for one funder could mean economic satisfaction. Satisfaction for another funder could be that the product goal was met within so many timestamps. Um, and so you could say like, oh, okay, these funders are now dissatisfied and like fall out. Or you could take a sort of macro approach and say like 20% of the time, uh, 20%, 20% of the time the population is dissatisfied. The current numbers of funders are like dissatisfied. So stochastically, probabilistically, they fall out of the number of funders and move back into the potential funding like state. So like that could give you some sort of fuzziness and like people's willingness to be a funder. But I think like um, the ideal goal for any project is that this external funding process is not critical to their existence. That instead it all comes down to the thing that comes from treasury funding. And treasury funding, which isn't really depicted here, comes from really the economic model. But I think in the beginning, it's unrealistic to think that funding from external sources does not end up being like the primary driver of like funding.
Yeah,
You
you
know,
have no savings to fall back on when you start, basically.
yeah, there's no economic model because you don't have a business really until you have product market fit.
Yeah.
So it's like a it's like a weird, I guess, kind of spanning function where it's like, oh, I have these two variables x and y, and they've got to sum to one, and so like, oh, in the beginning it's like 99% external funding and 1% economic value from something. Maybe it's a Google ad, and it makes you 50 cents. And then over time, the ratio falls, so it becomes more like, oh, it's 80% external funding, 20% revenue, and then it becomes 40, 60-40, 50-50. If you're lucky, 60-30, and then finally, it's all just like revenue. There's no longer that reliance on satisfying the funders and being in that funding cycle. So then you would just move out of that like particular stage. And how quickly you get out of that stage is really dependent upon like how quickly you find product market fit and are able to generate sustainable revenue. But I guess my suspicion is that generating sustainable revenue is actually kind of tricky as a product, but I'm not exactly sure as to uh, what all of the blockers are in each particular like business cycle. So one of the things that's kind of puzzling to me, and just like kind of thinking aloud, is thinking about podcasts and the Patreon model. So lots of individuals are able to sort of monetize podcasts that have very low, um, I guess, overhead or development costs, so to speak. And so it seems like that is almost entirely outside of paying like sort of the rent to the Patreon to like provide the service of like managing funds, broadcasting and listing like updates and things like that, and gatekeeping. Uh, there is not a clear idea of this need for external funding or the external funding cycle outside of like some initial stage of the capital to either quit your job to do this full time and like get a RIT and do that risk. So that's kind of interesting. And so like if you look at software cycles, they're kind of like different than in those cases where there's large amounts of money raised, but it could be that the potential upside is so much larger than thinking about your first 1,000 fans. So I think it's maybe an issue of scale saying that.
Where'd you find that template?
I made it.
Ah,
but
cool.
but the and I'll open source this. That's another thing I've been wanting to do is take these kind of templates that I'm kind of putting together because they're all in Draw.io
Ah,
and
right.
then
You
like
mentioned that.
share the XML for it, so anyone can then pull it down locally, do their own thing, and then it's inspired by this here usage. This the Ethereum economic model. I'll drop this one in chat.
Yeah.
Can you see my screen?
Hmm.
So my thinking here, you can see that I have also the stages, and they have these like policy and user decisions. And so the validator process to me seemed a lot like the funder process, where you would have number of validators in the activation queue, and then this environment that decides like the initial states of these numbers and the policy of like who switches over into what. And then here is like kind of like the funding contribution process, I thought. It made sense. So instead of having each validator be its own sort of necessary agent, you could look at them in aggregate and say, oh, we have this many validators, and then they have on average this kind of balance, and then the environment will say this is staking, and you can get the aggregate amount staked. in our case, it's not staking. It could be, but it's actual like funding. So that could be like NFT sales. It could be angels. It could be your own wallet. All of those kinds of things. And then
Mhm.
like when you kind of look towards these things are like user decisions. And so I was kind of thinking about modeling contributors as kind of the same sort of idea of like committee rewards. So it's like, oh, if you're a contributor, there's a lot of user decisions there, which is could be broken down by um, individual skill level, could be like interest, and it could be like economic motivation. Um, I'm trying to not get into the weeds there about the psychological motivations of all of the contributors, but to try and look at them more abstractly and say like, okay, they're all development incentive like motivated broadly. Um, and then if you look here, it's kind of an interesting thing, which is a breakdown into like the process, the actual mechanics. So I'm thinking of doing a two-tiered differential spec, one that talks about the actual like system level type of things. And for me, the system type of thing looks like this original diagram where there's a contributor, there's this contribution process, and this is like what's driving the consumption of development funds and the individual monetary. And so this like impact process and all of this becomes kind of a weird system level abstraction. Um, in terms of the actual like rating, so that would go, and I think a chart like this. And then the actual decisions would be these kind of pink things, which are user decisions. And that would be more like, oh, I'm deciding to give this contributor an impact rating of 7. And that has the effect of giving them this kind of reward for their development cycle. Or there is, uh, within the mechanics of the system, if you have been a long-term contributor, you get a bonus point for making a recent contribution. So it's all like aggregated in terms of like how much more you get paid for the work. So for instance, me building someone a website with 20 years of experience or 17 is going to cost a lot more than someone that has done it for like 1 year or 2 years. And then that's just on the basis of necessarily you're paying for the potential quality improvement um, or like the potential increase in quality that comes with experience.
Mhm. Really cool. I'm impressed that you were able to draw so many parallels between the Ethereum economic model and your Pico DAO.
Yeah,
Cool.
I was
Actually,
really struggling.
yeah.
Yeah.
Well, I'm kind of curious, like on this topic. That's something that I think is like the biggest challenge about doing these like self guided learning things. Like, do you have any strategies for like solving a problem that you don't even really know what the problem is yet? Or like getting, I don't know, how to find inspiration for problems like yeah, like digging into resources to find inspiration for to solve the problems you're trying to work on.
Yeah. Let me see. I would say be curious.
Yeah, just kind of like no time is wasted. Go down all the rabbit holes.
Go down all the
Yeah.
rabbit. And I would say, like, how I actually came to the Ethereum economic model was I was talking with the group that I'm doing with this university where I'm trying to help students like learn about like sort of tokens and blockchain and things like that. And I was trying to explain to them about sort of inflationary and deflationary economics and looking for a way to like sort of model these. And then I was thinking about like, oh, like, well, how did they model the like the gas change from EIP like 1559? And I was like, oh yeah, they did a whole bunch of and so I was like looking around, and then I ended up stumbling across the Ethereum
Mhm.
economic model, and then there was the whole like cadCAD class thing, and then I looked at that, and then I think I came back to it when I finished the CLD. I think I tried to do this much earlier, but I didn't quite have the right process. And then I saw like the work you did, Peter, for the predator prey with CLD, and I was like, that looks pretty rad, and that would be uh, super nice and useful for helping me understand more of the dynamics um, to like sort of model the system.
Mhm.
Because the way the journey started, kind of follow along in order, kind of started here with these kind of
Mhm.
stock and flow diagrams or like flow charts, and then it kind of skipped down to this, and then I tried to jump the gun and do this, which is like kind of right, but it kind of overloads too many concepts into like sort of one. And then I kind of hit the pause button and revisited this with the feedback from the group, and that came this. And then once I started looking at this, I remembered that I had seen this,
Mhm.
and I had done the modeling class for this. There's the master class
Oh
that
yeah.
they have another one like the boot camp, but it uses RadCAD. So I had done that course, so I was like, oh yeah, and this is together the model. And then I was like, oh, this is very similar to what I'm doing more or less. The names and the labels and the functions of what people do are slightly different. But I think the technique for doing the aggregation without getting necessarily lost in lots and lots of little agent states um, was like a really, I think, useful abstraction to
Mhm.
start from um, versus necessarily having to go bottom up. That I could just like shortcut things, keep them more abstract, and go like sort of top down with some like very clearly labeled assumptions.
Mhm.
Um, yeah,
Cool.
so that's what I would say.
Yeah. Yeah. No, it's always helpful to hear other people's process. I think this week I myself like hit a little bit of a roadblock, like what do I do next kind of thing, and like I have an idea of the problem I'm trying to solve, but I don't know what the solution is. So yeah, it's helpful to just hear other paths, and it definitely is pretty random. So cool.
Cool.
I have a new appreciation for that diagram. Because as I'm looking at it, based on what I've been looking at in cadCAD, it appears that it captures the structure of these partial state update blocks that cadCAD works with.
It does. It's like it really does actually capture them for the most part, and you can kind of model it. This one is actually a lot more abstract than the ones that come from like the cadCAD like repo. I think maybe like this one is more. This one's like all right. there is, I think, one more that talks about actual partial state updates and things like that. But I found that that was just too uh, deep into the weeds. So I liked RadCAD's like abstraction a little bit more. Um, maybe I think RadCAD has one. Uh, model and this. Well, anyways, I can't find the example. I just like the way that they grouped them together without talking necessarily specifically about cadCAD's like state update. And so one of the concerns that I had though was that this might be too tuned to cadCAD to be generally useful. But I think going through the process of the differential spec has helped me like start to see everything as its own like sort of distinct dynamical system as a cog in the wheel. So it's helped me to create like more or less classes, classes or like
Yeah, or
functions.
components. Yeah,
Yeah,
yeah.
components.
A cog in the wheel or the system, that's a good way to think about it. Each of those is little mechanisms that are affecting outcomes.
Yeah, and I couldn't find any other type of view this. That's the thing that was disturbing to me. Well, not disturbing, but but I was looking for something to be a little more broad, and I think the closest thing is the stock and flow. But I find this a little bit easier because then I have like very distinct like borders. And the cool thing is like if you look at the diagram, there are like ways for these to communicate with each other. So like for instance, I found this to be useful too. Um, so they do it in two different ways. So one is this like base reward. As you can see, this is also a state variable. And you see base reward here and base reward here. So these are the same state variables. But you can also kind of just like draw the line into the input here versus like putting it there. But yeah, I think the componentization of without necessarily having to draw the links, like I just find it useful. Otherwise, I feel like I get lost and I'm like trying to figure out what wire goes where.
Yeah.
Mhm.
So if anyone has any other suggestions, send this differential spec. I'm all ears. But it seems like it as a process is something that is just broadly very useful. Even if I weren't using cadCAD, that it would be like a useful thing to have.
Yeah. So does this help you? Sorry, I'm taking up, I think, some time, but does this help you then transfer what you know about the model into a differential equation? Like this helps with the math spec part of it?
I I'm not sure. I think to a certain extent it could,
Mhm.
but I think like the thing that it helps with is I think lining up all of the variables
Mhm.
and like isolate the functions. Yeah, yeah. So I would say yes, it does in the sense that if you were to view each of these system inputs as like an f of x of some sort,
Yeah.
that's gonna do a transformation to something.
Yeah.
This basically
Variables.
says, yeah, that given some x, given some y, f of x of y is equal to
Mhm.
um, this output.
Yeah.
And so you could then translate this as its own distinct function. And then I think if you were to try and like tie it together, you would just map each of these to their own differential equation or their own method. And then you would then go about in some sort of way.
Mhm.
And that could be saying like, oh, I see I'm taking number of validations. Um, these dimensions are the same, which I think maybe, yeah, this will help with GDS. Yeah.
Cool. Yeah, I'm
But I
curious
haven't
to see
gotten
that
there
part.
yet. Still
We'll find out.
I think in the context of simulation, it's telling you how you get from step T to step T plus 1.
Mhm.
yeah.
Yeah, definitely.
Yeah. Let's see if I just like drop that and then I'll turn the 4 over.
Yeah, if you drop the I don't know, template or
This is the chart, and then there's a which explains like what all the variables are. Actually, it's just the whole thing is like really well done. Um, let's see. I'll drop the theorem economic model. And go here. And then, because they also have a mathematical model,
cool.
which talks about the same things of the system, its states and the inputs, stuff like that. So I'll link this directly. I should probably link this.
Sweet. All right. Anything else? Any other updates? Are you all wrapped up?
I'm all wrapped up. That's
Cool.
it.
Awesome. Yeah, it's been really cool to see the progress and the yeah, also interesting to just hear you explain the process of learning what steps to take next and all that. How you related it back to previous projects and things. So very cool. Let's see what we got. I think I was second on the list. Yep. Okay, so I don't have a ton to show, but I will share my screen anyways. So I was kind of, this week I was doing, as I said, a little bit of like what I'm trying to just recap like what I'm working on, and I was kind of like, I guess, soul searching on my learning topic, and yeah, because I think the predator prey model was what I picked to work on, and I was hoping to just like get the experience of mapping out this system so it's ready for implementation of 1.0 in cadCAD. Yeah, calling it cadCAD 1.0, saying like getting to that point, but I guess I didn't really know what I was doing in the end, so I had worked on this lucid chart, and this is kind of where I organized like some of the system diagrams and just like went with a random structure of like questions and assumptions and conditions, and did a few diagrams, and then actually made some models in Excel, and then I was like, okay, what do I do next? And I was kind of realizing, and we talked about it a little bit last week too, but I was realizing that what I'm most interested in, I think, with like in this space is actually more about the process than it actually is the specific project. So I think like both of you have picked topics that you're like personally interested in, like project wise, and then you're like going through and working on those like in the context of those projects and just like figuring out how to understand those systems and eventually model them. But I guess I'm realizing that I'm like most interested in more about the process and just getting experience applying the token engineering process to systems. And yeah, so this week I sort of zoomed out and created actually a different learning journey, a new learning journey, which is, I guess I'm calling applied TE process. And so this learning journey is more about, it's more focused on getting experience applying the token engineering process. And yeah, applying what I know about the token engineering process to these beginner level systems to gain a better understanding of how the process looks and feels in practice. Tyler mentioned this a bunch when he was joining the first few weeks. Basically that it's an art, like this whole system mapping and design stuff is all an art, and there's no like exact next steps, which we're, I think, learning and getting experience through in the study group, which is awesome. But yeah, so I'm just, I guess, trying to find iterations of that process. And yeah, and then also along the way, understanding prerequisites, knowledge and skills needed. So I'd say actually a lot of my time the last 2 weeks I've spent just like watching YouTube videos and reading documents about like systems engineering or behavioral economics and like, yeah, different engineering design processes and stuff, just because I'm kind of trying to still wrap my head around like what in the token engineering field is new, and like what is actual token engineering, and then what is just previously defined knowledge and skills from other academic fields. And I come from an economics and math background, but I also really just like jumped into the token engineering space like, I don't know, 2 years ago now, from like a very clean slate of knowledge. So I feel like I'm in my head, everything is token engineering that I have discovered in this so far in this space, but really that's just not true. Majority of it is already has already been figured out, and it's not necessarily new knowledge and skills. And so I guess along the way in this learning journey, I'm hoping to just get a better understanding of how those different pieces of the academic puzzle fit together, and then where token engineering sits in general. So that's been pretty interesting. I realized that it would be really cool to have mapped some of that out, like what I've learned, and maybe that's what I'll do, try and do for next week, actually, just kind of go back through all the videos. I have all the links saved, but just go back through what I've read and watched, and like maybe create some sort of like Venn diagram thing of the various fields around token engineering, and then and then some of the new content that is more like specific to token engineering. So that's more or less my new learning goal. But conveniently, as part of the steps for that learning goal, I'm experimenting with these beginner level systems, and one of those is obviously predator and prey. So the work that I've done there isn't going to go wasted. And I've learned some already just by messing around with that model. So that's definitely valuable. But I'll probably pick another one or two models alongside to just kind of apply the process and see what more I learn. So that's part of my plan. And then another point for the learning journey is, accumulating these resources and notes on the skills and knowledge needed. That's kind of the map that I was just talking about, which would be cool to have as a resource. And then eventually, I guess this is maybe where like your project is, Zane, in terms of like it's an actual token economic system. It's not a biological system or natural system or whatever. So I think eventually I'll get to something like that where it's more like undefined and you really have to like build it from the ground up. But to me, that just seems like a big, like a little too much uncertainty, and I don't really know what project I would work on first, or like what topic I would pull on first. So that's kind of why I am going with these existing systems to get some experience with the process in systems that exist, and then maybe I'll experiment with systems that are new. And yeah, so that's the steps that I will take. And then, yeah, I started linking some of the resources here that I've been digging into just to learn more about systems engineering. But then the next update I can share is related to the token engineering process. Actually, where is it? Yeah. So in my old learning journey document, which I guess I'm still using technically, I started to outline a bit more, a bit more concretely the token engineering process from how I understand it, and from the various resources, like be it lectures that lectures, calls, papers that I've read over the last few years about the token engineering process. And I kind of broke it down to, I mean, actually just like pulled this from one of the videos, I guess, but broke it down into these steps of like discovery phase, design phase, modeling phase. And this is actually, I think, something that Block.Science has like created themselves, defining it as these three phases at least. And and then highlighting system goals, system requirements, some of the visual tools, and then getting more into the variables, states, actions, metrics, which I guess is closer to like what you were just showing us, Zane. So you're probably in this design phase, and so kind of working through these steps and applying this to first the predator-prey model, which I think should be pretty quick because I already have a good idea of how that system works. And then I will move on to a system number 2, which is undecided what exactly that is yet. But I, can imagine that I'll get to that in like probably the next week or so. So it should go quick. But so this was the other new thing to show is just this is the first very rough outline of the different phases of the token engineering process that I'm going to try and apply this template to a couple different systems and see how it goes from there. So so that's where I'm at with my plans for the study group. And I guess in the end, like not a lot to show, but there was more like thinking and watching and reading and just trying to like collect my thoughts about where to go next. So I'll pause there.
I think one of the challenges I've found in trying to pick this up is there are so many options. So thinking about just where I was getting started, I don't know, 4 months ago or something like this, working through fungible versus non-fungible, proof of work versus proof of stake. And then when you get into proof of stake, all the different dynamics that can occur in that world. And so it seems like it's ripe for getting stuck in a sort of discovery and maybe partial design phase, because there are so many options. And Zane touched on something earlier that resonated with me, which is around the token life cycle and being able to describe how that life cycle unfolds. And it may be different for different token economies, but probably there are various states, just as there are various states in a human life cycle, that could be used to sort of ground the concept and then think about it and how would it vary in different token economies, basically. So even something as fundamental as that, about how are tokens born, right? And how are they used over time, and how do they die? What is that process like, and what are the levers that you have to control that, and the implications of those choices?
Mhm. Yeah. Yeah, I feel like I've read something about token life cycles. There was I think some lecture on that actually. Um, hmm. Are you,
You can have a situation where you're continuously mining tokens, right? So
mhm.
they're born on each block, or you can have an initial issuance of tokens, and so those live on in some form. But maybe there are additional issuances, so that's more like a securities model where you do an initial offering for investment, and then maybe you do subsequent rounds over time.
Mhm. Right, like throughout as the life cycle continues, issuing more.
Yeah.
Yeah. So do you think that would be, you're saying that's like another topic, potentially to look into for?
In the context of describing a learning journey that's grounded in token economics,
Mhm.
that seems like an area that it would be useful to have a reference point for that topic.
Mhm. The token
So when
life
you're talking
cycle.
about the process, there will be a process of deciding what's the token life cycle going to be in our token economy.
Mm. Yeah. Yeah, so
Yeah.
I I feel like maybe that's something that comes up in like the goals. Let's see where I have it. So like system goals is one of the first steps of the discovery phase. Um, and I guess yeah, right here actually I mentioned like long-term stability for the predator and prey populations. So maybe your system goals are things, or could be broken down by life cycle dimensions, like early, mid, long term. Um, and maybe that's one way to incorporate that into the process.
Yeah, and in terms of what you had laid out, um, much of that would you categorize as discovery? How much of that goes into design? Just almost like a best practices guide for approaching the token engineering process.
Hmm. Yeah, yeah, definitely. Um, so yeah, I guess I'll see how this goes. I'll see what I learn, like applying this framework to a couple of um, yeah, a couple different systems, and um, yeah, I guess I just like it helped to like zoom out a little bit and um, think of my learning journey as more of like iterating on this process through a few different systems rather than trying to focus on one system, because I wasn't as mm, familiar with or like motivated by the predator prey specifically. Like I don't really need to like learn a lot about that system. But what I'm most curious in, I'm realizing, is the token engineering, this process, and yeah, getting more iterative iterations of applying this. So kind of changing the perspective of the learning journey is mostly what I've been doing, I'd say.
Cool. You're back to discovery.
Yeah, back to square one. But yeah, I guess token engineering process is iterative, so.
It is. It's just like right back into the same cycle.
Yeah.
It's like, yeah.
You always come back a little bit wiser than the last time around, hopefully.
Yeah, exactly. I hope, at least.
Yeah, for sure.
But I don't know. I'm. It's kind of funny. I'm like realizing I'm not that, or at least so far, I haven't quite figured out the most effective like strategies for diving into these completely or pretty unknown topics like without structure. I mean, I always have enjoyed doing that and like end up putting myself in positions to do that, but it's still like a very tough skill to hone in, I think. So, working on it.
I've been happy with this unstructured process.
Yeah.
I feel like, I started out thinking like, oh yeah, this is how this is gonna go, and now I'm like completely nowhere where I thought. But I'm in a much better place, I would say, in terms of like the route to get towards the goal.
Yeah, and actually, I maybe this is also a good spot to bring up another topic. So I was also just wanted to do a quick check-in. I know we did some feedback last week, but this is week number 8, I guess, I think week 8 of the program. And so it's been going on for 2 months, which is cool. And I feel like we have been covering interesting stuff. But I just wanted to also double check and make sure that like short term, you guys are still feeling good about this, like it's been valuable. And I think in my opinion, I think we've missed the goal a little bit, like more like the goal was misshot. Like the intention wasn't really possible of like creating, all of this like cadCAD documentation and open source models, at least like not yet, but maybe that'll happen eventually in the future. But I feel like maybe we've missed that a little bit, but we've still like learned a lot, and where we ended up is actually probably better. It's like been more natural to get here, I think. And can kind of go from here. But curious what you guys think.
I think for me, it's been like quite an eye opener because like originally I thought, okay, I had done like the RAI workshop and like kind of played around with some of the cadCAD stuff. I tried to write my own simulator a while back, and so it's like, okay, I was fairly, I thought, familiar, but then I think I underestimated the amount of things that I need to sort of fully conceptualize like what's going on with the token economy. And then like I had never like really formally tried to sit down and like model the process. I had always done like very small scale like sort of systems. Like, oh, here's how a bonding curve works. And I had one with like agents and stuff like that would do like buying and selling, but not really like, oh, okay, well, here's kind of like what I think is going on. Here's what I think is like captured. And then how do I go about like putting it in a form that allows me to like actually simulate this? And so like that's been really like useful, and I completely underestimated how much time and energy I should be front loading. I was like, oh yeah. It's like 1 week, 2 weeks on this, and then the rest of the time will probably be spent building. No, it's more like 2 months on this, probably like hope maybe ideally 3 weeks, 2 weeks on building.
Yeah.
But because I like actually know like how the pieces should probably connect, there's less of a fuzzy like build system or something that doesn't quite capture what I think is like happening. I can at least like evaluate whether or not the dynamics that I set up like match. In a way, like unit test each of the processes. Like before, I wouldn't have had unit testable like processes. Yeah.
Mhm. Yeah, it's certainly a huge endeavor to like build these, especially like full system models, like when you go beyond the components of like markets or AMMs or bonding curves or whatever. Like those are just one tiny subsystem within a full full ecosystem of, yeah. So it gets
Of
quite
stuff.
complex of stuff.
Yeah.
Yeah, totally.
Yeah. Yeah. So I would say like my takeaway would be this was like a great experience. Simply for the fact that like there's not enough like sort of talk
Mhm.
or like sort of
Collaboration.
working, yeah, or even just like process evaluation of like, oh, this is how you develop computer programs.
Mhm.
Oh, this is how you develop token economies.
Yeah.
And it's like, oh yeah, here are some things to consider so your token economy isn't doing things that you don't want. You might want to put your token economy into functions, into
Mhm.
classes. And in this case, it's like you may want like stock and flow diagrams. You may want CLDs.
Mhm.
Yeah,
Yeah, like
yeah,
none of
and
that
it,
exists yet.
yeah, yeah, and I think it's kind of nice also that it's not like 100% tied to cadCAD.
Mhm.
Because it seems like right now, I guess I haven't written any code,
Yeah.
but I think that all the specs and diagrams would allow me to, as you did earlier with the ABM, well, not the ABM, with the predator prey model, just use like Python in the
Mhm.
sense that if you need to do that, I think it would be way easier with cadCAD just because they're going to handle like the runs. It's a bit of a framework for me to apply the updates in the order that I need them to be applied.
Mhm.
And then if in 1.0 they'll have the type system, so that will be also
Yeah.
equally nice.
Yeah. Yeah, that was also not really on purpose, but part of the learning the the learning process of the study group was realizing that like doing the CAD modeling was not going to be the main focus of the study group. I think it could be if there were already a bunch of predefined models that just needed to be coded. But yeah, this is kind of where we ended up, which I think was a good outcome.
Yeah, I think if it had been um, based around something like the cadCAD hacks,
Mhm.
it would have uh, it, it would have provided a more prescribed pathway through learning cadCAD.
Mhm.
But the initial objective around doing things around cadCAD 1.0 was, as it turns out, untenable because
Yeah.
1.0 is not far enough along to do anything with, right? Um, so yeah, in the face of that, then I think we just sort of organically moved towards doing some systems modeling and in my case a little bit of implementation
Mhm.
to explore these concepts. And in terms of where I am in the journey, it's still useful because I still have so much to learn.
Mhm. Yeah, for sure. Yeah, I mean it's just like valuable to get to coordinate or communicate with other people in the same space. Like Zane, you were just saying that definitely doesn't happen enough, I think, within the token engineering community. So
Well, and I think that not a lot of this has been figured out. There's a lot that's out there, so there are a lot of examples and references of things that people have done, but I haven't seen anything that talks about what you would call a best practice, or
Mm-hmm.
or the counterexample, things that you absolutely should avoid. And we still see on a pretty regular basis things going pretty catastrophically wrong in one token economy or another. Um, and so those things will iron out over time,
Mm-hmm.
but I don't know that anybody, probably somewhere in academia, people are watching these things and somebody's going to write the paper that says, here are best practices, here are worst
Mm-hmm.
practices, things. Um, but all that is forming in real time at this point.
Yeah.
And so to the extent that we're engaged with it, maybe we can capture some of that.
Yeah. Yeah, definitely. I think that's the best practices are definitely forming. It's just a question of like how and when they get broadcast, because like people are doing like the token and like that very high level token engineering, um, Block.Science, for example, and like Gauntlet and other like consulting service firm are, but I guess as the information flows out of those organizations, then it'll end up in the community more.
Yeah, it's really like sort of interesting, but like, yeah, I think that's like a huge issue, which is like just like general uncertainty and not a lot of clarity as to like what is a best practice. Just like
Mhm.
I think a lot of people looking at like what worked before and just kind of putting that together or not deviating too far from that.
Yeah. Yep. And one of the risks there is you don't know if it just worked for a certain period of time,
Yeah.
and something catastrophic is going to happen in 6 months or whatever, or at a certain scale. Um,
Mhm.
yeah, that is worrisome for me. And in part, what drives me to learn as much as I can about the topic of token engineering,
Yeah.
because taking responsibility for a system like that is an enormous responsibility.
Mhm. Yeah. Yeah, definitely. Okay, so then uh, I think that this is valuable, and seems like we are, even though we're all on like slightly different paths and whatnot, like we're still finding it interesting to connect and share progress and stuff. Um, so do you want to continue meeting? We could put another like 2 or 3 week counter on it, see where we end up. Um, I mean, like overhead wise, it's really pretty minimal. I mean, I've honestly not even been able to, unfortunately, haven't even been able to commit too much time to like the studying part of it. But like even just the organizing and whatever is like just really minimal. So um, that's not really a factor in whether or not we continue. It's more just like, do the folks in the group, want to keep going or try and reassess, maybe switch up the frequency, cadence, etc. What do you guys think?
One of the questions on my mind is whether there are ways that we can be more efficient with it. So I think when this kicked off, there was a group of attendees who probably had more expertise than we have in this area. And since they're not attending at this point in time, is there an opportunity to engage people with more expertise going forward, or is that just sort of where this group is settling, is we're carrying it forward as best we can?
Mm-hmm. Yeah, so we do have some connections to Block.Science researchers who are aware that the program is going on. We actually have Barlin is signed up to join us next week, if we're still around, and if we continue, if we want to have more of them, we can. I think it's been a bit of a balance of like trying to find open engineers and so it can definitely happen more. And Barlin signed up next week, so if that's something that we want to do, then can make that happen.
Yeah, I think those are useful. I can't think of the name of the guy who
Danilo,
a few
probably, or Tyler. Yeah.
It was, you say Lilo?
Danilo.
Lilo. Yeah, that was quite good and useful.
Yeah. Yeah, cool. Okay. Well, Barlin should be here next week, and then I can try and recruit a few more, maybe join for the second hour of the future sessions as well.
Yeah, I agree. That would be useful to see like what other people that are like in it every day kind of do or like doing.
Cool. Nice. Sweet. Then it sounds like we will keep trucking. Cool. All right. I actually didn't mean to go into that in such detail. I know cadCAD, you wanted to present today as well, give some updates. So
yeah,
I will pass the floor. Okay. Cool.
Let me see if I can share my screen here. So as you remember, I'm looking into liquidity, and I guess more generally, just trying to get an understanding of the different token economics mechanisms. And so in the past week, well, prior to that, we've talked about some of the diagrams around bonding curves, single and multiple, as well as the staking systems and liquidity pools. And I had started on a cadCAD implementation using the 4.28 version, trying to layer in some cadCAD modeling against a molecule the company, bonding curve example. And so in the past week, I went through this process of identifying what the agent actions are, what the state variables are. And so this is something that would feed pretty naturally into the types of diagrams that Zane was sharing today. And so I may go back and update with that kind of perspective. But it also, and this is what made me make that connection, as you lay out the different policies and how are the policies going to operate in terms of inputs and outputs, and what are the things that need to be updated with each step through the simulation. So those concepts, I think, translate pretty naturally into I want to say systems differentiation diagram, but I think that's not the right title.
Yeah, differential spec.
Thank you. So,
terminology.
It's a made-up term, by the
way. Yeah, so happy to take comments on actions, just to set a little more context. Trying to keep it as simple as I can right now in terms of what agents are doing, and updating the state of the system. And so what I've got, and I can actually switch windows and show you in a minute, what I've got is something where it runs through cadCAD and updates state on the agent side as well as on sort of the bonding curve or the token economy side. So before we look at that, any comments or questions on the agent actions, state variables, policies? Okay. If I can switch. So this is still a bit rough. Oh.
Nice.
And so what I used as a starting point is this model of a bonding curve, a sigmoidal bonding curve, in a handful of different scenarios. So starting at the simplest level, in what they had implemented, they call fees taxation, basically. So So in a case where you're not collecting any fees around the bonding curve, you get a price graph showing how the price changes as the supply changes, and this nice S sigmoidal shape that goes with it. And then related to that, you can calculate what's the overall, what they call collateral or capitalization based on the supply. How does that grow? And there are a handful of scenarios that are encoded here so that you can get a little more sophisticated and say, well, maybe I'm going to operate my I curve a little bit differently than my cell curve. And so what kind of a difference does that make in terms of collateral on buy and sell sides? How does that then change the fund collection through these fees that are being collected? So if it's a constant taxation rate, as the overall capitalization grows, if it's a constant taxation amount, as capitalization grows, then the actual rate of taxation will decline. So your denominator is growing while your numerator stays the same, basically. How does that impact funding? And then different scenarios. And so thinking about this from a systems perspective, these bottom two graphs, especially the one on the lower right here, shows how you'll be accumulating funds based on choices that you're making with the bonding curves and how you set the different parameters for that part of the system. So let's just go back here. If we look at decreasing taxation, you get a nice steady ramp of funding, and then it kind of levels off past a certain supply. So we reach this more steady state condition. If we look at what if we increase taxation over time, then we start out with a low amount of funds to get started, and then ramp as the token supply increases. This one's kind of interesting in that it ultimately creates a sigmoidal funding graph. So you kind of start low, you have a period of accelerated growth, and then you start to level off based on how you're managing. You're sort of concentrating fees around this point after you've received a decent amount of adoption. So your early adopters are in, and then you've got your mid-stage adopters coming on, and you're going to charge them more, basically, and generate funds from them.
And the taxation rate on the left is like out of like basically 100%, so it's like a 45% tax.
Yeah.
Okay.
And so all these are adjustable. So if you think about cadCAD's ability to sweep parameters, you could, in theory, be building surfaces out of these things to explore how the surface lays out under different conditions. So to get to this point, as I mentioned last week, I'd taken their sample code and refactored it so that the way it was originally written, every one of these different scenarios had its own sort of code set that went with it. And so I generalized that into a class system with different parameters. And the goal of that is to ultimately be able to swap in different bonding curves, so non-sigmoidal, various different shapes and things like that, into this system. And then what I have running right now, with rather crude output, is just a single agent that, based on how much capital it has and the token price, will decide whether to buy or sell on any given step through the simulation. And apologies for the table not lining up here, but if we look at this column where I'm highlighting, user starts out with 0 tokens, then buys 10, then sells them and goes back to 0, buys 10 again, just based on where the price is and how much capital they have available to them. So next steps, I want to get the token supply and pricing adjusting according to the bonding curves, and then start to introduce graphs around what I'm currently capturing in the table here. But again, trying to make it as simple as possible as I'm sort of learning how the cadCAD framework runs and what the right way is to structure the code around that. And then, so once I've got it how I like it for a single agent, I'll look to scale out multiple different kinds of agents like we talked about last week, where maybe there are different populations of agents that have different motivations for wanting to participate in the token economy, and that affects how they trade tokens.
So right now, the agents are they just greedy in the sense that they try and utilize all of the supply that the number of tokens that they can buy in a period, or is it just like random?
They're incredibly basic. There's nothing stochastic about it at this point. It's basically a simple heuristic that says if I have enough capital to buy tokens without going to zero capital, then I'll buy. Otherwise, if I have tokens, I will sell.
Okay, cool.
But yeah, as it goes forward, thinking much further down the line, having a more stochastic component around the behavioral aspects and starting to get into things like causal inference and how can you model agent behavior through those mechanisms would be a very cool area to explore, I think.
Yeah, this is cool. I think I didn't realize that, or I hadn't considered that the buy and sell curves could just be different curves. You don't actually have to keep them on one curve. I was like,
you don't see it that much. Back to what we were just talking about in terms of process and practices, it's another question for me. Why not? Why don't you see that more than you do?
Yeah. I was like, wow, this is like exploding my mind a little bit. But I was like, oh yeah, actually, why am I using a single curve when I could just like disincentivize selling? I just like have that sell like grow at a much slower rate. Or like at a faster rate. Like you sell, it goes down steep real quick.
Yeah, and as you mess with some of the parameters, so if you shrink your token supply, for example, and you kind of straighten out that sigmoidal aspect, if you've left the curve inflection point well out there, but you can actually get a lot of different shapes out of this conceptual shape, if you will.
I have a question. So I know you're like mostly exploring and testing, breaking the rules of parallel curves, and just learning more about bonding curves at this point. But is there like I'm just curious if you have thought of specific questions or scenarios that you want to hypothesize about or dig into specifically, like if there's a specific type of curve or a specific pair of buy and sell curves that you'd like to dig into and learn about more.
It's a little more general than that at this point. So the way I'm thinking about it right now is these are idealized, right? So if price depends on supply according to these curves, that's an idealized structure. Depending on how tokens are allocated, and this gets back to that life cycle of the token question, if tokens do not continuously generate in this way, but tokens get minted and burned along here, so there's potentially a back and forth along the x-axis. This governs how things will travel along that x-axis, but what happens in these bottom two graphs, I think, will be changing because of that dynamic. And so that's my starting point, is to look at that. And Also, trying to keep that grounded in still looking for best practices, right? Like, what is the right way to manage a token life cycle and to do issuance and things like that. Um, but to the extent that you have actors in the system that are behaving dynamically around their buy and sell choices, and you may deviate from these idealized pictures in the bottom section here because of the agent actions around buying and selling.
Yeah.
Obviously, if your agent stopped buying at 50K, for example, then you only reach this point on the graph.
Yeah. Okay, follow up. Do you have any, have you thought at all about primary secondary market interactions? I think
Meaning,
this is, at least from how I understand it, bonding curves are primary markets where the token is issued and burned. But assuming it's like, I don't know, a ERC20 token or whatever, like on a public blockchain, people can create their own markets, or there will be markets for it, paired with other tokens. And then, there's secondary markets where you can buy and sell at a different price relative to the bonding curve.
So that's where the liquidity pools come in, at least in my mental model.
Okay, cool. Yeah.
So this would be step one, and working through adding staking and liquidity pools around that primary market as sort of secondary functions.
Right. Okay, cool. Awesome.
So that's where I'm at.
Nice. That's an awesome dashboard. Really cool.
I'm excited.
Yeah.
So, I was less disciplined than Zane. I appreciate the discipline that Zane has in doing all the diagramming. But since cadCAD was new to me, I wanted to get my hands on it and understand a little bit more about how it worked and how to program it, basically.
Yeah. Well, props to you for diving in.
Well done. Can I ask a question?
Yeah, go ahead, Alyssa.
Yes, well done, cadCAD Liz and Zexstar. I followed the presentation, and I've been able to learn one or two things that will guide me in my task. I wanted to find out cadCAD Liz, is this cadCAD as well? You have such simple interface and all that.
So that interface is from a Python package called. That interface is from a Python package called Dash. There's actually an example. I just found this yesterday. There's an example in the cadCAD hacks that Peter posted into the chat where they show how to put a Dash interface on top of a cadCAD model. I think it's a predator-prey model even. So there is an example out there of how to do that.
Well, thanks. You dropped it in the channel.
Let me double check. Actually, I can find a link to that specific notebook and put that in the channel.
Please, I wouldn't mind, and I wouldn't mind to. Okay, I can be your DM as well, or disturb you a little. Thank you.
Yeah, it basically, that package uses Plotly and wraps it into HTML components so that you can get a web page out of it.
Cool.
Okay.
I found the link. I'll drop it in.
Cool. All right. I think that might be all for the week. So yeah, as I said, Barlin will be joining next week, which is really cool. And yeah, I guess, I mean, he can probably just comment generally about it, but if you guys have specific questions or like, yeah, about your models or just the token engineering process in general, or cadCAD, I mean, he'll probably give you a bit of an intro, but he was like more or less the inventor or one of the inventors of cadCAD, the original framework. So he, yeah, has a lot of experience with it. Probably ran the first cadCAD model ever. So that should be cool.
Yeah, that sounds great.
So you said Zagram's coming?
Barlin, Matthew
Barlin.
Matt Barlin. Yeah.
Okay.
Yeah.
Cool.
Yeah, so they'll be excited. He'll be excited to tune in. I actually need to double check. I think I think he's planning to come for both hours, but I'll double check and make sure it's not just one.
Yeah, even if it were for one, I think that's useful. And that kind of a structure, not bad, where you have an expert for the session, and then we can do our updates in another part of the session.
Yeah, true. That's kind of what we had originally planned, and then I guess lack of signups, but we didn't really. I didn't really like push people too hard, but I think they're interested and excited and like really glad that we're doing this. And yeah, so I'll just spread the word a little bit more, and I think if we market it as 1 hour instead of 2, maybe it's a little more enticing. So great call. Cool. I think that's all then.
Great.
Yeah, we'll see you guys next week then.
Thanks.
Sounds
See you
good.
next
Have a
week.
good evening.
Ciao.
Have a good one.